Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph rational expressions. Now, when graphing rational expressions, obviously the best thing that we'd like to do is use a calculator. But if you're taking a test or an exam or something, you don't have a calculator, knowing how to graph it without a calculator is very important. And not only is it just like important to know how to graph it without a calculator, but the steps and all the information that you use to graph a rational expression is really what's going to be the most important. And we've discussed a majority of that information up to this point. So really, graphing rational expressions is really just kind of putting everything together so therefore we can sketch the graph. So I have 3 examples for you. And basically what we're going to do is we're going to follow a 7-step process into identifying how to graph the rational function. The first thing we're going to do, the first step, is we are going to identify symmetry. Now, to identify symmetry, what we're basically going to do is plug in f of negative x into our function. Now, if we plug in negative x into our function and we get f of x back, we get the exact same function, then the graph is said to have, or not said to have, but it does have vertical symmetry, meaning it's symmetrical about the y-axis. If we plug in negative x and we get the opposite of the function, that means everything has been negated, then the function is symmetrical about the origin. Now, this is very helpful in, one, just kind of identifying how the graph is going to look and the shape and the feel of it. But also, it's going to be important for us to be able to check our answer. Make sure that if we don't have a symmetry, that our graph doesn't have symmetry. Or if we're supposed to have symmetry, make sure our graph has symmetry. So what we're going to do here is I'll plug in f of negative x into my function. So I have 3 of negative x divided by negative x plus 1. I go and simplify. I get negative 3 of x divided by negative x plus 1. So you can see that by plugging in negative x, I have positive, negative, positive, negative. However, the 1 is still exactly the same. So my function has not totally been negated. So therefore, in this example, I have no symmetry. OK, and we're going to test symmetry for all of these. The next step is we want to determine what the y-intercept is. Now, remember when we were graphing linear equations, especially linear equations in standard form, one of the easiest things to do was to identify the intercepts, and then connect them and then graph. So to identify the y-intercept, we set x equal to 0 and we solve for y. To identify the x-intercept, we set y equals 0 and solve for x. So to identify the y-intercept, we're just going to plug 0 in for x and then simplify. Now understand, though, that we're dealing with a function. So basically, our f of x is the same thing as our y value, right? Because you could look at it as like an f of x axis instead of a y axis. So basically, though, when I plug in x here, what I have is, or 0 for x, I have 3 divided by 0 over 0 plus 1. Well, 3 times 0 is 0 over 1, which equals 0. So therefore, my y-intercept is going to be y equals 0. Or if you're graphing on the f of x function, it would be f of x equals 0. Pretty much identical. Step number 3 is going to now identify the x-intercept. So remember, identifying the x-intercept, we plug 0 in for y. So in this case, maybe I am going to only have to do 2. I was going to try to do 3 equations, but I think I might be able to do 2. Well, let's get on with this. So x-intercept, y equals 0. So now I'm going to plug 0 in for my f of x. Or if this was an equation, it would be y. But remember, y and f of x are pretty much interchangeable. Just depends if we're talking about a function or a equation. So I plug 0 in for that. So I have 0 equals 3x over x plus 1. Now, this one gets students all the time because they say, how do I solve for x now? Well, basically, we've got to get rid of x plus 1 in the denominator. So to do that, we're going to multiply by the reciprocal. So we'll multiply by x plus 1 on both sides. Well, x plus 1 times x plus 1 over 1 here, those are going to divide out equal to 1. That obviously goes to 0. So we'll be left with 0 equals 3x. Now, to solve for x, I'll divide by 3, divide by 3. And my y-intercept, or my x-intercept, I'm sorry, is x equals 3. OK? So now when we're going to go ahead and graph this, basically now what I have is I have the x-intercept, I have the y-intercept, and I know that it's not symmetrical. So the next thing we want to do is now go ahead and determine our asymptotes. So the first asymptote we're going to want to identify is the vertical asymptote. So remember, the vertical asymptote is when the denominator equals 0. So you basically go up to your function and say, all right, my denominator is x plus 1. So you're basically going to set x plus 1 equal to 0? Well, I can go ahead and solve. Subtract 1, x equals -1. Yeah, I'm definitely going to have to only do 2. So then the next one is going to be the horizontal asymptote. So the horizontal asymptote, remember we have to go back and use the rules of our rules for horizontal asymptotes. So therefore we look at the powers of our rational function, and remember, or the degrees, basically. So remember, when you look at the degrees, and the degrees are exactly the same, you're going to take the coefficients of your two leading terms. So therefore, since these degrees are the same, my horizontal asymptote is y equals coefficient of my numerator divided by the leading coefficient of my denominator, which in this case is a 1 as well. So basically, I'll have y equals 3 over 1. So I can say 1 is equal to 1. So using the horizontal line test, I'm going to take my coefficients, leading coefficients, which would be a over b, which is 3 over 1. So it's y equals 3. All right. So I have my horizontal asymptote, my vertical asymptote, x-intercept, y-intercept, and symmetry. So now, basically, what I'm going to do, you know what, let's go and get this here. So now, basically, what I'm going to do is I'm going to go ahead and graph the information I have. OK, so by graphing the information I have a y-intercept at 0. I have an x-intercept at 0, or y-intercept, x-intercept. Oh, I'm sorry, my x-intercept so my graph crosses the y-axis at 0, but my x-intercept is at, oh, what the heck am I doing? Sorry about that. So my x-intercept is also at 0. I have a vertical asymptote at -1. So I'm going to go over to -1 and create a vertical dashed line. And I have a horizontal asymptote at y equals 3. So I'm going to go up to 3 and create a nice horizontal asymptote. OK? So now, basically, what I like to do here is I know I have 1 point here. Basically, now what I want to do is go ahead and pick at least 2 points to the left and to the right of every vertical asymptote. So fortunately for here, I already have 1 point at 0. So I just need to pick one more point. So I'm going to pick f of 1. So I'm going to say, what is going to be the value when x is equal to 1? Or f of 1. Make it look like that when x is equal to 1. So now, to find that point, basically what I'm going to do is figure out what f of 1 would be. So you could do 3 times 1 divided by 1 plus 1. Well, that gives me 3 over 2. So when f equals 1, I have 3 halves. So it'd be 1.5 here. Now I'm going to pick 2 points to the left. So if that's -1, let's do -2 and -3. So we'll do f of -2. So it's 3 times -2 divided by 2 plus 1. And then I'll do f of -3. So that equals 3 times -3 divided by -3 plus 1. OK, so basically, I'm trying to figure out what are my coordinate points. So when x equals 1, y equals 3 halves. When x equals -2, I end up with a -6 over -1, which equals 6. So I have at -2, I get -2, I get positive 6. So 1, 2, 3, 4, 5, 6. OK, at -3, I end up with -9 over -2, which is approximately 4.5. So at -3, 1, 2, 3, I'm at -4.5. 1, 2, 3, 4, 4.5. OK? And if you could keep on graphing these, I noticed that, again, that the form here that they're going to go by is going to look like 2 hyperbolas. And that's just under my knowledge here connecting. Because remember, the points, when you're graphing points, remember the points have to attract. They have to go towards the asymptotes, right? So my 2 points have to connect, but then they're going to approach my vertical and my horizontal asymptotes. OK? So there you have it in that example. And then, therefore, we're good to go. OK. So I found the exponent is y. Now, one other thing, too, is let's say, well, why don't you just plug in points? Well, the problem with just like randomly plugging in points or randomly making a table is you could, just because you're picking points, might not give you the information. So it's very helpful to know where your asymptotes lie and then pick points to the left and to the right of your vertical asymptotes to really see the shape of the graph. All right, so let's go into the next one. I'll try to move through this one a little bit quicker. And then I'll actually probably erase all my work right there and just sketch the graph. So the first thing is we want to identify symmetry. I'm not going to write in symmetry, so maybe that might help me out. So we now kind of know what 1 is, which is the symmetry. So we do f of negative x equals 4 times negative x divided by negative x squared minus 1. So what we end up with is a negative 4x divided by x squared minus 1. So again, we don't obtain the exact same function, nor do we have a function that's totally negated. So therefore, there's no symmetry. OK, again, step number 2, find the y-intercept. So the y-intercept, you're just going to plug 0 in for x. So I'm going to do f of x equals 4 times 0 over 0 squared minus 1. Well, I have 0 over 0 squared minus 1 is negative 1, which is 0. So my y-intercept is x, is y equals 0, or f of x equals 0. Then the next one is now going to do the x-intercept. So I'm going to plug 0 in for f of x. And then I have 4x divided by x squared minus 1. Again, the same process. You have your denominator. Just multiply by your denominator in the numerator on both sides. That goes to 0. And then that divides out. So you're left with 4x. Divide by 4, divide by 4. X equals 0 is your x-intercept. So again, we're going to have the same intercept for x and y. Step number 4 is to find your vertical asymptote. Again, basically what we're going to do is we are now going to vertical asymptote. So we're going to set x equal to our denominator equal to 0. So I'm going to say x squared minus 1 equals 0. Then I can just solve. I could use difference of two squares, or I could use my square root method. So I have x squared equals 1. Take the square root, take the square root. X equals plus or minus 1. OK, next step is to find my horizontal asymptote. Actually, you know what? I think I'm going to be able to fit this in here. Horizontal asymptote is now we look at, again, the degrees here. So now you can see that my numerator has a smaller degree than my denominator. So therefore, smaller degree than my denominator. So therefore, it has a, so my horizontal asymptote, when your degree in the numerator is smaller than the degree in the denominator, you have a horizontal asymptote at y equals 0. So that's my vertical asymptotes, and this is my horizontal asymptotes. Y equals 0. All right, so let's go ahead and graph this. OK. So to go ahead and graph this, again, the best thing to do is to graph your x and y intercepts first, which is at 0. I have a vertical asymptote at positive 1. I have a vertical asymptote at negative 1. And then I have a horizontal asymptote at 0. Now, I already have 1 point. I already have 1 point at 0, but it might be important. It might be helpful to kind of determine another point. So basically, I'm going to use my calculator in this case to just at least help me out as far as the math goes, because I'm not going to want to go through all of the mathematical work here that everything's going to show. But what I will do is I'll do 2 and 3. So I'm going to have to pick 2 points to the left and to the right. So basically, what I'm going to want to evaluate for is, just like you're creating a table. But now my table is going to contain the points. I'm going to want to make a table of -2, -3, +2, positive 3. And then I'm going to want to at least pick, I only have 0 here, so I'm probably going to want to pick negative 1/2 and positive 1/2. So basically, I'm going to want to evaluate for what is f of negative 3, what is f of negative 2, what is f of negative 1/2, what is f of positive 1/2, what is f of 2, and what is f of 3. So basically, I'm going to plug in all those values in for x, and then therefore, I'm going to plug all those values in for x, and then find the y value so I can plot the points. And let's see here. OK, so basically what we have here is negative 3. Let's go ahead and do that. So when I plug in negative 3, so if we're going to go ahead and plug in negative 3, basically what I'll have is 4 times negative 3 is going to be a negative 12. Over negative 3 squared is 9 minus 1. So that's going to be a negative 12 over 8, which equals a negative, let's see, divide by 4 on top and bottom, 3/2. Negative 3/2. So at negative 3, I'm at 1.5. OK, now let's go do negative 2. 4 times negative 2 is negative 8. Divided by negative 2 squared is going to be 4 minus 1. That equals a negative 8 over 3. I'm going to do a decimal approximation of that. Negative 8 divided by 3 is negative 2.66. That's negative 1.5 if you're looking at decimals. So at negative 2.66, so at negative 2, I'm going to go down to negative 2. And then negative 0.66 is going to go like this. Okay? Now, again, using my reasoning like I did up here, remember this graph has to connect these two. And then they also have to approach the asymptotes. So therefore, again, this graph is going to look something like this. OK, so now the reason why I wanted to use my calculator again was to determine the 1/2, because that's not really going to be as, actually, it's not really that bad. So 4 times 1/2 is going to be, or 4 times negative 1/2 is going to be a negative 2. Over 1/2 squared is 1/4 minus 1, which is really negative 2 over a negative 3/4. And then you'd multiply by your reciprocal, so that's going to be a positive 8/3. I don't want to, I guess I have time to show you my work, I guess. So to get the negative 3/4 off the bottom, I'll multiply by 4/3 on top and bottom. 2 times 4 is 8, and then 3. So therefore, you're left with a positive 8/3. So at negative 1/2, I'm at 2.66. So 1, 2, 3. Then it connects to 0. Then let's do positive 1/2. So that's going to be a positive 2 over 1/4 minus 1. Well, that's going to give you, negative. No, it gives you a positive 2. So that becomes negative, right? So that becomes a negative 8/3, because 1/4 minus 1 is still going to be a negative 3/4. So therefore, 1, 2, 3. So that's going to look like that at negative 1. And then we go ahead and do 2 and 3. So 4 times 2 is going to be 8 over 4 minus 1, which is positive 8/3. And then over here, that's going to be exact same, but it's going to be positive. So it would be positive 1.5. So at 2, I'm looking at 2.66. And then at 3, I'm looking at 1.5. OK? So again, we know this pattern. It's going to look like that. But now I have a pattern where basically I have points here that are connecting. But remember, they have to approach the asymptotes. So what we can look at this is actually going to form the shape of like a cubic. And that's why you could say that they don't have symmetry, because even though these look like they have symmetry about the origin, this cubic messes up the symmetry. That's why this case has no symmetry. So there you go, ladies and gentlemen. That is how you use your 7 steps. Step number 6 would be choosing points, which is right here. And step number 7 would be connecting so they approach the asymptotes. I didn't write those down. But that's how you use your 7 steps to graph rational functions. Thanks.